The three basic types of probability. Hello everyone, thanks for clicking this video. Do not hesitate to like and subscribe if you are new here. These three basic types of probability includes joint probability, conditional probability, and mutual exclusive probability. Joint probability refers to the probability of two or more events occurring together. It talks about two or more different probability events that are jointly determined. That means the probability of one event occurring is the same as the probability of the other event or events to occur. For instance, in a fair game of chess between A and B, there is every probability that A would win the game. In that case, the probability that A will win is still the same as the probability that B will win, which is 1 over 2 for each side. Another good example is when two fair dice are thrown at once. The probability of getting a 6 from the first die is same as the probability of getting a 6 from the second die. The formula for joint probability is giving us the probability of A and B equal to the probability of A multiplied by the probability of B. Let's solve a problem on joint probability. So the question says, a bag contains 5 red balls, 3 blue balls, and 2 green balls. What is the probability of drawing a red ball and then a blue ball? So the question requires us to find the probability of red balls and blue balls. In that case, red balls become our first event, while blue balls becomes our second event. And then the total number of balls, which is 5 plus 3 plus 2, will give us 10. Have the formula at the back of your mind. The probability of a red ball is equal to the number of red balls, which is 5, divided by the total number of balls, which is 10. The probability of picking a blue ball is equal to the number of blue balls, which is 3, over the number of balls left, which is 9. You're probably wondering why 9 balls? Why not 10? One ball has already been drawn. Remember, the question says, what is the probability of picking a red ball, then a blue ball? That means the red ball has to be picked first before the blue balls. And if a red ball is subtracted from 10 balls, that leaves you with just 9 balls as your total. Next, you impute your results for the two events into your formula. 5 multiplied by 3 will give us 15. 10 multiplied by 9 will give us 90. 15 in 15 will give us 1. 15 in 90 will give us 6. You can decide to leave your answer in this way, or you can divide it. When you divide it, you have approximately 0.17. Conditional probability refers to the probability of an event occurring, given that another event has already occurred. Now, the difference between joint probability and conditional probability is that in joint probability, the two events has equal chances of occurring. That's why they say they are jointly determined. But in conditional probability, it involves the occurrence of one event before another event. That means one event has to occur to trigger another event to occur. For instance, you could say Mr. A went out with an umbrella. given that it was raining. Now you could see the events of rain has caused Mr. A to go out with an umbrella. One event has led to another event. Another example is Mrs. A can't see, given that she is blindfolded. One event has led to another event. Mr. and Mrs. A got married, given that they were in love. The formula for conditional probability is giving us the probability of AB equal to the probability of A and B divided by the probability of B. The question says a fair coin is tossed twice such that an event occur of having head and tail. If another event of having at most one tail occur, find the probability of having both head and tail given that at most one tail occurred. First thing you want to do is to bring out your sample space. Since the coin was flipped twice, your sample space will be head head, head tail, tail tail, and tail head. What the question is asking us to find is the probability of having head and tail given that at most one tail occurred. So our first event will be having head and tail, and then our second event will be having at most one tail. Since event A is talking about having head and tail occurring together, then our possible outcomes will be head tail and tail head. The probability for A would now be the two possible outcomes, which is head tail and tail head, divided by the total outcome, which is 4. By the time you divide 2 by 2, it will give you 1. 4 by 2, it will give you 2. Now, the second event, having at most one tail. This means everything that is going to be covered in the possible outcome should be at least one tail. It shouldn't be more than one tail. And if it's going to be at least one tail, then the possible outcomes would be head head, head tail, and tail head. That leaves us with 3 outcomes. So our probability for B, which is having at most one tail, would be equal to 3/4. It is also very important that you note the word and means intersection, and the word or means union. So in that case, wherever you see A and B, it can also be written as A intersection B. Or if you see A or B, it can also be written as A union B. We've solved for A and B separately. Next thing to do now is to find the intersection of A and B. Find the intersection between A and B. First, we need to bring out our events. So event A is head, tail, and tail head, while event B is head, 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 tail, and tail head. Now, intersection means similarities. What do they have in common? So our A intersection B now would be head, tail, and tail head, because that's what A and B have in common. Now, the probability of A intersection B would be 2/4. 2 divided by 2 is 1. 4 divided by 2 is 2. Our probability for A intersection B would be equal to 0.5, and then our probability for B will settle at 3 over 4. By the time you divide that, you have 0.75. Next, you impute your probability of A intersection B and the probability of B into your formula, which will give you 0.5 divided by 0.75. By the time you do that, you have approximately 0.67 as your final answer. So that's how you solve for conditional probability. Mutually exclusive events are those events that cannot occur simultaneously. In other words, if one event happens, the other events cannot happen. Events are mutually exclusive when both events have nothing in common. Therefore, mutually exclusive event is bound to occur inexclusively. That is, the occurrence of one event doesn't necessarily stop the other from occurring. Mutually exclusive event makes use of or and not and, as in A or B, not A and B. An example is Mr. A won the race, but he didn't participate. Now, the two events here are Mr. A won the race as event A, and event B, Mr. A didn't participate. This is impossible. The two events cannot happen at the same time. There's no way Mr. A would win a race he did not participate in. So the only way it could work is if Mr. A won the race or Mr. A didn't participate. Another good example is if giving a job to Mr. A stops Mr. B from getting a job. See, this is mutually inexclusive because the occurrence of Mr. A getting a job doesn't necessarily stop Mr. B from getting a job. So it's inexclusive. The events does not affect each other in any way. And the event has nothing in common. So therefore, the event is a mutually exclusive event. Another example is rolling a die once and getting a 3 and a 6. That's impossible. You can't roll a die once and have two outcomes at once. It's either you have a 3 or you have a 6. The formula for mutually exclusive probability is giving us the probability of A or B equal to the probability of A plus the probability of B. Let's make an example with the tossing of a coin. When a coin is being tossed, you either arrived with a head or a tail. You can't get both head and tail at the same time. It's either a head or a tail. So in that case, our first event will be a head, while our second event will be tail. The probability of A would be equal to 1 over 2. The probability of B will also be equal to 1 over 2. Next, you bring in your formula, which is probability of A or B equal to probability of A plus probability of B. We have our probability of A and B to be 1 over 2. 1 divided by 2 is 0.5. The sum of 0.5 is 1. So that's how you solve for mutually exclusive events. That will be all for this video. Do not forget to like, and if you're new here, Please subscribe and click on the notification bell so you'll be the first to get notified when next I drop a new video. Thanks for watching.